Well, now we will introduce some tools that can be helpful in order to automate more than one stage in the machine learning workflow. The first package is AutoWeka. AutoWeka is an approach for the simultaneous selection of a machine learning algorithm and its hyperparameters. Combined with the Weka package, it automatically yields good models for a wide variety of datasets. AutoWeka considers the problem of simultaneously selecting a learning algorithm and setting its hyperparameters, going beyond previous methods that address these issues in isolation. AutoWeka does this using a fully automated approach, leveraging recent innovations in Bayesian optimization. Our next package is AutoScikit-learn. AutoScikit-learn is an extension of AutoWeka using the Python library scikit-learn. Um, AutoScikit-learn frees a machine learning user from algorithm selection and hyperparameter tuning. It leverages also recent developments in Bayesian optimization, meta learning, and ensemble construction. It is quite similar to AutoWeka. Another tool is Transmography. Transmography is an auto machine learning library running on top of Spark. This is not Python. It was developed using uh, an approach that enhances machine learning developer productivity through machine learning automation. This framework has an API that enforces compile time, type safety, modularity, and reuse of the modules that we can create with this tool. From our point of view, this is the most complex tool from our list. And remember that we are looking for simple ways of doing machine learning. So my recommendation is to explore other tools before. Now, a very complete and more simple tool is MLBox. MLBox is an auto machine learning library with three components: preprocessing, optimization, and prediction. MLBox is written in Python. It provides features to do fast data preprocessing, cleaning, and formatting. It also helps with highly robust feature selection and leak detection. The hyperparameter optimization is very accurate, and it can manage high dimensional spaces. MLBox uses also a state-of-the-art predictive models for classification and regression, like deep learning methods, stacking, and light gradient boosting machines. This is one of the only tools that claims to be helpful in the first preprocessing stage where cleaning and formatting has to be done. So we highly recommend to go into the details of this tool. Well, now another tool, H2O. You know that H2O is a machine learning and data analytics platform. It's big. It's a big platform. But H2O has an auto machine learning module that provides automated model selection and assembly. So this module in H2O can be used for automating the machine learning workflow, which includes automatic training and tuning of many models within a user specified time limit. So you can specify the time limit for this tuning and training. It uses something that is called stack ensembles. Ensembles is a machine learning method that use multiple learning algorithms to obtain a better predictive performance that could have been otherwise obtained from any of the constituent learning algorithms. So it uses many weak algorithms to build a strong algorithm. Um, Many of the popular modern machine learning algorithms are actually ensembles. For example, random forests or gradient boosting machines, they are ensembles. And finally, The main objective for our talk, it is Teapot. Teapot is an automated machine learning tool written in Python also. It optimizes machine learning pipelines using genetic programming, which is the first part of our talk. Teapot will automate most of the tedious part of machine learning by exploring thousands of millions of possible pipelines to find the best one for the data that we have. It depends on the time that we want to run Teapot, if we want to explore just hundreds or thousands of millions of possibilities. As a result of running Teapot, you will get a Python script. That Python script implements the best pipeline that was found for our data. And by running that Python script, you can execute the final selected model. If we need more optimizations, what we can do is to manually change the code of the final script by writing more Python code.